In this video, we are going to see how to draw the graphs of linear inequalities. But before, let's refresh our knowledge about linear graphs. On two-dimensional plane, we draw the linear equation graphs as follows. For the first equation, y equals 5 must cut the y-axis from 5. So the graph will look like this. It's going to be parallel to the x-axis, whereas y equals -2 will pass from the y value of -2 and it will again be parallel to x-axis. So it's going to be y equals -2. As you can guess, the graphs of third and fourth equations will be parallel to y-axis. So for x equals 3, it's going to be here, cutting the x-axis from 3. So that's going to be, let's say, if we choose blue, that's going to be like this, right? And for -3, which will be here on the x-axis, I am going to draw the graph again on vertical with, let's say, green, like this. Right. So if it is y equals a number, it's going to cut the y-axis from that number. If it's x equals a number, then the graph should cut the x-axis from that number, as shown here. When it comes to y equals x, it's going to be this line passing through the origin, right? And if you notice, it is like x value is 2, y value is 2, or x value is 5, so is the y value because y is equal to x. So that's why it's going to be this graph. Whereas y equals -x will be passing through the origin, but it's going to be the opposite of y equals x because of this, say, negative sign. Whenever x is a negative number like -3, y will be negative times negative, +3, or whenever x is a positive number like 4, y will be a negative number because of the negative sign. For an equation like that, we have to make an xy table. So remember, we were to choose x values on our own, so we're going to say x will be -1, 0, and 1. These are the numbers I choose. You may choose some other numbers, but make sure these are simple to calculate, because what we're going to do is, for every x value we choose, we have to substitute them into the equation. So it's going to be like, for x equals -1, y is -1 plus 3, which is 2. For x equals 0, y is 0 plus 3, which is 3. And for x equals 1, y is 1 plus 3, which is 4. These will be my coordinates: -1 to 2, 0 to 3, 1 to 4, which I'm going to plot on the graph. And then I'll join those points that I plotted here, here, and here as per the coordinates, and then I joined them to get the graph of y equals x plus 3. Now, so it says the point xy satisfies the following inequalities. So x is greater than 1, x is less than 3, y is less than 4, y is greater than x. In part A, it says, illustrate these inequalities on a graph, shading the region that satisfies all 4 inequalities, and label your region R. So let's try that. So here are our inequalities, and I have to draw these as if they are linear equations first to find out the borders of the region. So basically, x greater than 1, I will consider this as x is equal to 1. So I'll draw this. And then x is less than 3, I'll consider this as, not from here, here. X is 3. And then for y is less than 4, I'm going to consider y equals 4. And for y greater than x, I'm going to consider y equals x. So it will pass through the origin and all these diagonals. Right? So these are my lines. Let me write these down not to get lost. So this is y equals x. This is y equals 4. This is x equals 3. And this is x equals 1. Now, this point that the question is talking about is in between these inequalities in a region that I have to find. So it's x greater than 1. I consider all the values greater than 1 for x. And x is less than 3. I consider all the values less than 3. If you consider these two together, it's going to be like 1 less than x less than 3, meaning x is in between 1 and 3, as in this region. Right? Now, it says y is less than 4. So I also have to consider within this region y is less than 4. So it must be here. So actually, so of course I have to consider this bit as well. This last one will tell me where the region is. Now, y is greater than x means that the y values must be bigger than x values. So it's gonna be on top of the y equals x line. So it's gonna be as in here. Right? So the region I'm talking about is this part. So this is the region that the question is asking, which I'll label with an R. In part B, the question says, the point P lies in the region R. The coordinates of P are integers. This is important. So it's not decimals, no fractions, just integers. Write down the coordinates of P. So, when we look at this region, we can only see, let me clarify this a little bit. Now, just because I can't have the borders in my solution because there is no equality like that, right, in our inequalities, then I have to consider a point in the region which the coordinates would be integers. So actually it's this point I'm talking about. So the point P is here with the coordinates being, well, that's gonna be a 2 and that's gonna be a 3. So it's gonna be P is 2 to 3. We're looking for this point. Another example. In this question it says draw the graphs of these straight lines and then hence shade the region R corresponding to the inequalities given as per the equations, right? So here are the inequalities here. So let's draw these first. X is equal to 2 will be this one. Y is equal to 2 will be this graph. Y is less than 7 will be this graph. And y equals x minus 1 will be this graph. Now, this time I'm going to be shading the unwanted regions. Like if it is y greater than 2, I'm going to shade y is less than 2. So this region is a region that I don't want. And y is less than 7, I'm going to shade y is greater than 7. So I don't want this region, right? And then it comes to x is greater than 2, so I don't want x is less than 2, so I shade that region as well, right? And we have y equals x minus 1, the inequalities y is greater than x minus 1. Now if you're not sure, you can make a test. You can do this. If that borderline does not pass through the origin, which in this case it doesn't, you can use the origin, which is 0 to 0, and substitute here into the inequality. So it's going to be 0 greater than 0 minus 1, which will be 0 is greater than minus 1, which is correct. Correct means your point that you choose is in the region that you want. So this means if it is the region that I want, then I'm going to shade the region that I don't want. I shade this region because I don't want this region. So wherever I don't shade will be my region. So it's gonna be this trapezium here. That's my region. So you can either shade the wanted regions and look at the intersection of lines, or you can shade the unwanted regions and take the region which is not shaded at all. Now is your turn. Please draw a two-dimensional coordinate plane, then draw the lines, and then shade the regions appropriately. Thank you.